Okay, so today we are starting our review for our mid-unit assessment on motion graphs, and we're just going to be focusing on finding the rate from a table and from a graph. Okay, so we have this table or graph for Terence's motion, and we're just going to start by translating these yellow points to the table. Okay, so if I look at my first point, I have 0, 2, I have 1, 3, I have 3, 7, I have 5, 9, and I have 8, 8. And then my last point is 10, looks like 10, 7. Okay, and I don't know why that extra space is there. We don't need that. Okay, so we're going to go through each one of these questions, and we're going to find the rate both from the table and from the graph. So we're going to start with from 0 to 1 second. So I'm going to draw in my slope triangle for the graph. Okay, remember when we're finding the slope from a graph, we're looking at the rise or the fall over the run. So if I look here, I'm rising 1 and I'm running 1. Okay, if I go over to my table, from 2 to 3, I'm adding 1. And from 0 to 1, I'm adding 1. So from both the graph and the table, my rate is 1 divided by 1, which gives me a rate of 1 foot per second. Okay, I'm just going to repeat this for every interval that I'm asked. So from 1 to 3, I'm going to draw in my slope triangle. Okay, so I'm going up 4 and over 2. I'm going to go back and look at my table. Okay, from 3 to 7, I'm adding 4. 1 to 3, I'm adding 2. And it's good to see the connection both between the rate on the graph and then also the rate in the table to kind of see that connection. Okay, so I take my rise over my run, or my change in y divided by my change in x, and I get 2 feet per second. Okay, next one. Okay, we're looking from 3 to 5 seconds. So I'm going up 2 and over 2. If I look at my table, 7 to 9, I'm adding 2 between those values, and 3 to 5, I'm adding 2 again. Okay, so to find that rate, I'm going to take 2 divided by 2, which gives me 1 foot per second. Okay, things are going to change up a little bit here. So from 5 to 8 seconds, you can see now that we're actually falling instead of rising. Okay, so when we fall, remember that's in that negative direction. So we're falling 1 and we're running 3. Okay, and if I look at my table from 9 to 8, I need to subtract 1. And then the change from 5 to 8 is plus 3. Okay, so to find that rate, rise over run, rise or fall over run, and then change in y divided by change in x, they both give you the same value. Get in the habit of leaving your rates or your slopes as fractions. They're going to be much easier to graph that way. Okay, so negative 1/3 foot per second. And our last one. So we are looking from 8 to 10. So we're dropping 1, running 2, and showing that at the table, we're dropping 1, adding 2. And again, leave it as a fraction. Negative 1/2 of a foot per second. Okay, so the next two questions ask you to determine where Terrence was moving the fastest and where Terrence was moving the slowest. So remember, when we're looking at our slope, we look at the number for the speed, and then we look at the sign, positive or negative, for direction. Okay, so just because something is a negative number does not mean that it's going slower. It just means the direction is different. Remember, if we have a negative slope, we're moving towards the target. If we have a positive slope, we're moving away from the target. So we're really just looking at the number to answer this question. So we have 1, 2, 1, 1/3, 1/2. And we're trying to figure out where Terrence is moving the fastest. Well, our slope or our rate is our speed. So we want the largest number. So the largest number would indicate the faster speed. So it looks like 2 would be our fastest rate, and that is happening between 1 and 3 seconds. And we can say that because it has the larger or the largest slope or the largest rate. Okay, so now we're going to look at the other end of that. Okay, we're going to look at the slowest speed. So out of 1, 2, 1/3, 1/2, what is the smallest number? Okay, now remember, the sign tells us direction. So we are just looking at the number portion of our rate. Okay, so if we look at 1/3 and 1/2, so try to decipher which one of those is smaller. I like to think about sharing food. So if I really want to split a brownie with my friend who has a brownie and they're like, oh, well, do you want a third or do you want a half? I want a half because a third is smaller. Okay, so 1/3 is going to be a smaller speed than 1/2 foot per second. So 5 to 8 seconds. And that would be the smallest speed or smallest slope. Actually, let's say speed because the slope includes the sign as well. So if we think about a number line, right? If we think about a number line, negative 1/3 is going to come before negative 1/2. Like negative 1/3 is technically, if you include the sign, is technically a larger number than negative 1/2. But when we're talking about rate, we're talking about when we're talking about our speed, we're talking about just the steepness, not the direction. So 1/3 is actually smaller, which means slower. Okay, so moving on to number 2. So basically you have someone who is running a motion detector for a skate, just like Terrence. They did not record all the data, but what we do know is that the rate is constant. Okay, so that being said, we should be able to fill in the table. So we should be counting by the same change in y and the same change in x throughout our table. So to fill in the missing pieces, we jump from 3 to 9. So trying to figure out what's going to, fit in there. So looking at that, I think it's pretty quick to jump at that it should be 5 and 7. Okay, so that's one way just to think about, skip counting 3, 5, 7, 9. Another way to find out those missing pieces would be to graph the 2 points that you already have. Okay, so if I have 0, 3, and I have 3, 9, 3, 9 doesn't fit on here, but I have a pretty good idea of where it is. Okay. So I can use that line from the 2 points that I've been given to kind of go in here and figure out what the value for x being 1 and 2 is. Okay. Right, and then all you have to do is find the rate. So we can do that the 2 ways that we did it above, change in y divided by change in x. Or we could draw a slope triangle and count the sides. So that would be a 2 and a 1. So we divide 2 by 1, and our rate is 2 feet per second. Okay. The next example, I think it's a little more straightforward what the blanks should be. So 8 to 6, we're kind of deducting 2. So 4 and 2. Going through the same process, we want to find the slope. So from 8 to 6, we're subtracting 2. From 0 to 2, we're adding 2. So make sure that you're still checking that change in x. Don't assume that it's 1. And then we're going to divide the change in x by the change in y, which gives us -1. So our rate, -1 feet per second. And then even though you have already found the rate, we still want to make sure that you know how to graph the line. So please, please, please make sure that you still graph the line on your homework tonight. Whether or not you use it to find the rate, we still want you to graph it. Okay? And maybe you're someone who likes to graph to use the slope. So down 1, right 1 would be your slope triangle. Okay, all done. Good luck.